Hello everyone. So this is the continuation of that video. So that's why I just recap and forward this things all, and I will move to the where I folded the things. Right. So until that one, we completed with a small simple example. Now, what I'm doing is, if I'm having a multiple loops and multiple paths, okay, handling if you are having a multiple loops and multiple paths, then how can you do this? There is a step-by-step detection method. If multiple forward paths are not touching loops exist, then first you need to get the each pk and delta k. That means each individual gains and also the summation gains you need to identify, and after that you need to identify the loop combination that don't touch, then you can able to get the total delta. So then if you carefully apply all the signs with respect to delta, then you will get the whatever the delta formulation based Mason gate formulation that you can apply to that one. So this can get a little bit of little bit of complexity, because there are, if you are having multiple loops and multiple pathways, then automatically what will happen is the number of loops may get increased, plus and minus that numbers may get increases, so that can be done. So to reduce the iteration process or anything, you may use a simple table to understand, to remove the iterative process or any disturbances or anything, or structure level to understand. Okay, so now we'll see a simple example that one. So complex, simple, not simple, complex example. If you see, this is one of the complex example which I'm going to do now. Okay, so here are some more complex SFG parts. Okay, if you see in this diagram, we are having a two forward paths, three loops, one pair of non-touching loops. Okay, so we can calculate P1, P2, delta 1, delta 1, delta 2, then apply the Masonite formula. That means first initially we need to see what are the forward, how many paths, how many loops, each and everything. Then only we can able to get the things done. Then only we can able to make. So there are two forward paths, right? So that's why we are having two P1 and P2. There are three loops are there that we will be taking into consideration of delta 1 and delta 2, and the total one pair of non-touching loop that will becomes under the delta. So these things can apply. You can get the Mason gain formula based output. You may automatically you will get the things done. Okay, so this is example 2. So when we go for the practical application, because you may think like it as a, this signal flow graphs is not able, not implemented anything, or not a just it is only limited for the theoretical purpose. Means no, it is wrong. There are some applications are there where SFGs are widely used. First one is the control system modeling. Okay, wherever we are implementing the control system, that we can easily understand that one. And next one is communication systems, because when it is a communication system, we may have multiple overlaps, multiple signal coming in, signal coming out. So these things that easily can done through the SFGs. And the next is circuit analysis. As you already know, in the circuit analysis we have the nodes, sub super nodes, and the branches, and multiple loops. Everything is there that easily can go through this SFGs. And digital filter. Digital filter is also a little bit of the same concept. It will reflect it as, so that we can use this one. But there are certain common mistakes when you are formulating, or when you are reducing the total signal flow graphs to the simple one. So what are all that means? So we need to identify the what are the touching loops. Okay, so what first we need to identify the touching loops. There many people may get disturbed here. So because some people may understood like that this may loop may not touch, or may touch, or something like that also can done. And also loop signs, if the loop is getting the plus sign or minus sign, that also we need to see. And then again, ignoring the feedback loops. So don't ignore the feedback loops, because the feedback loop plays a very big role when you are writing a reducing the block diagrams, or reducing the signal flow graphs, or whatever it will be. So don't reduce feedback loops. Always recheck the loop combinations before finalizing each and everything. Always recheck the loop combinations, whether it will be a non-touching loops or touching loops, or whatever it will be. So these things are very much important when you are doing this non-touching loop combinations. And don't forget the feedback loops. Okay, this way we can able to understand the signal flow graphs. Okay, and this is the final topic in the module 1. Maybe in a couple, one or two videos, I will try to solve the numerical problems by that thing. So that by this video you can simply that what are the theoretical will be there, that is theoretically it is finished. So in the next couple of one or two videos I will solve numerical problems to understand the both block diagram representation and also signal flow graphs easily. Thank you.